What's up, everybody? This is EchoLynx. Today we're going over the HTTP in detail room from TryHackMe. Let's jump into task 1. What is HTTP or HTTPS? The room gives a brief background on HTTP. It's the set of rules universally accepted for communicating with web servers to transmit web pages, HTML, images, videos, pretty much anything. When you reach out to a web server, you use either HTTP or HTTPS. Both stand for Hypertext Transfer Protocol. The S stands for secure, meaning the connection is encrypted. If you request something from a web server using HTTP and someone is monitoring the traffic, they can see everything in plain text. If you're talking to a web server with HTTPS and they're monitoring the traffic, they cannot see everything in clear text because it's encrypted. Once we get into tools like Wireshark, you'll see the difference. This is the universal way web servers send resources and how we, the users or clients, request resources. If we view the site in the task and see tryhackmetrack.com, we can look at the address bar. It says HTTP and not HTTPS, which means it isn't secure, hence the lock symbol with a dash through it. Clicking that reveals THM invalid HTTP cert. Copy that and paste it as the answer to the bottom question. Then it asks, what does HTTP stand for? Hypertext Transfer Protocol. What does the S in HTTPS stand for? Hypertext Transfer Protocol Secure. Answer those and you've finished task 1. Next up, task 2. Requests and responses. How do we ask for resources from web servers? How do we know what to ask for? And how do they know what to give us? URLs are a big part of this. When we make a request, we're asking for something, HTML images, and we need to tell the browser where to get the resource. A URL is predominantly an instruction on how to access a resource on the internet, and it can be broken down into parts. Most URLs don't use all features, but you may see any of them. The scheme tells us the protocol, HTTP, HTTPS, FTP, etc. User info can appear for services requiring authentication, username and password in the URL, though for general browsing, you don't need it. Host is the domain name or IP address you wish to access. Typically, we use a domain name, e.g. tryhackme.com, google.com, facebook.com. Port is specified as host:/port. By default, the web uses port 443 for HTTPS and port 80 for HTTP, so you usually don't type it. Technically, you could request any port from 1 to 65,535, but 80 and 443 are the standard defaults. Path is the file path to the resource you want. For example, /pre-security pathway /webmodule /HTTP in detail. The query string is extra information sent to the requested path. For example, $ID equals 1 to fetch the first blog post. Fragment is a reference to a location on the page, useful for long pages. Making a request can be as simple as get/http/1.1, method get, protocol version http/1.1, and the path /homepage. The first line of the request includes the method and path. For example, to get /admin, you'd request get/admin http/1.1. The host header tells the server which website we want, e.g. host, tryhackme.com. The user agent identifies the browser making the request. The referrer indicates which web page referred us to this address. The last line of a GET request is a blank line to signal the end of the request. A sample response begins with a status line, e.g. http/1.1200 OK, indicating success and echoing the protocol version. It may include server information, useful in fingerprinting outdated servers, the date and time, content type, what's being sent, text/HTML, images, video, PDF, XML, and content length, how many bytes to expect, helpful to confirm nothing is missing. A blank line separates headers from the body, followed by the actual data, e.g. HTML. Questions. What protocol version is being used? HTTP/1.1. Which response header tells the browser how much data to expect? Content length. Answer both to finish task 2. Task number 3. HTTP methods. Get requests, ask the server for information, images, PDFs, web pages, HTML. Post requests submit data to a server. For example, creating a new user, user25, with password 2000. If accepted, the server creates a new record. Put requests submit data to update existing information. For example, changing your password. Delete requests remove information or records if the server allows it. Many servers restrict this for safety. These are the most common methods. There are others you'll encounter later. Questions. What method is used to create a new user account? Post. What method updates your email address? Put. What method removes an uploaded picture? Delete. What method is used to view a news article? Answer those to finish task 3. Task number 4. Status codes come in categories you should know. 100 to 199 are informational responses. 200 to 299 indicate success. 300 to 399 are redirections. 400 to 499 are client errors, issues on our side, such as bad data or unauthorized access. 500 to 599 are server errors, issues on the server side. Common codes include 200, OK, request successful, 201, created, resource has been created, 301, moved permanently, redirect to a new location, 302, found, temporary redirect, 400, bad request, client sent something invalid or incomplete, 401, unauthorized, authentication required, 403, forbidden, no permission to view the resource even if logged in, 404, not found, resource doesn't exist, 405, method not allowed, e.g., server only allows post, but you sent get, 500, internal server error, and 503, service unavailable, overloaded, or down for maintenance. Questions. What response code might you receive after creating a new user or blog post? 201, created. What response code might you receive if you access a page that doesn't exist? 404, not found. What response code might you receive if the web server can't access its database and the application crashes? 503, service unavailable. What response code might you receive if you tried to edit your profile without logging in? 401, unauthorized. You can also click the View Site Examples to see how 403, 404, and 503 look. Finish those and you're done with Task 4. Task number 5. Headers are additional pieces of information sent with requests or returned in responses. Common request headers include host, which website is being requested, user agent, the browser or client, content length, how much data you're sending, accept encoding, compressions the client supports, and cookie, data the browser sends to help the server remember the session. Common response headers include set cookie, server instructs the client to store a cookie, cache control, how long the client may cache content, content type, what kind of data is returned, and content encoding, what compression the server used. Questions. What header tells the web server what browser is being used? User agent. What header tells the browser what type of data is being returned? Content type. What header tells the web server which website is being requested? Host. Answer those to finish Task 5. Task number 6. Cookies help a web server remember who you are. Example. The client requests a page from cookies.thm. The server responds with a page containing a form asking for a username. The client fills the form with the name Adam and submits it. The server processes the form and responds with a set cookie header, e.g., name equals Adam, and instructs the client to save it. From then on, every request the client sends includes name, equals Adam, allowing the server to personalize responses. For example, welcome back, Adam. You can view cookies stored in your browser via developer tools, and the room provides a view site to show how to access cookies in different browsers like Firefox, Chrome, etc. You can take some time to see this. Complete the question. Which header is used to save cookies to your computer? Set cookie. And you're done with task 6. Task number 7. Making requests. This emulator lets you craft HTTP requests using what you've learned: method, URL, and parameters, set via the gear icon. First, make a GET request to /room and send it. You should receive a 200 response and a flag in the data. Copy the flag and paste it as the answer. Next, make a GET request to /blog and use the gear icon to set the ID parameter to 1. Send the request, retrieve the flag, and submit it. Then make a delete request to /user/1. Send it and copy the flag indicating the user is deleted. Now we come here and make a PUT request to /user/2. And we come here and we change the parameter username equals admin. Send it and you'll receive confirmation that the user has been updated. Finally, make a post request to /login with username equals THM and password equals letmein. Send it to receive the "You're logged in, welcome back" flag. Copy and paste it. Once you've answered all questions, you've finished task 7.